The James Webb Telescope has basically revealed the clearest image of Proxima B in history, uncovering stunning exposures concerning this perhaps viable exoplanet. It obliges us as we set out on an endeavor through space to uncover the privileged secrets of Proxima B and check if it might be the next Earth we should take off into the vast expanse of space where a baffling planet exists in the habitable zone of its star Proxima Centauri. This planet isn't just any ordinary rock. It's Earth's cousin. Proxima B, located 4.2 light-years from us, is covered in mystery and wonder. Could it at some point be another Earth with oceans and life flowing across its surface? But wait, there's more. Proxima B isn't alone in its orbit around the red dwarf star. It has a companion, Proxima Centauri C, which could uncover even more secrets the star system holds. Perhaps there is another companion that we haven't found yet. The mystery doesn't end there. Proxima Centauri generates nearly the same amount of energy from its star as Earth does from the Sun. Could this really mean there's water on its surface? Perhaps life as we know it could exist beyond our solar system. As we journey farther into space, we encounter a totally new universe of exoplanets, planets that orbit stars other than the Sun, with 100 billion stars in the Milky Way galaxy alone. The opportunities for exoplanets are endless. Some even wander through space, untethered to any star, like rogue pioneers among them. Proxima Centauri B stands out as a truly astonishing and bewildering planet with a year lasting just 11.2 Earth days. Its distance from its star is much closer than Earth's distance from the Sun. This means that one side of the planet is perpetually bathed in light while the other remains in eternal darkness. Now let's explore Proxima Centauri, the star around which Proxima B orbits. Proxima Centauri is part of the Alpha Centauri triple star system. This system includes Alpha Centauri A and B2 G-type and K-type stars that appear as one in the constellation Centaurus and are the third brightest stars in our night sky. Proxima Centauri, also called Alpha Centauri C, is a red dwarf type star located 4.24 light-years from the other two stars, making it the closest star to our solar system. Proxima Centauri means the closest star in Latin, and it was discovered in 1915 by Scottish astronomer Robert Thorburn. Despite being the closest star to us, Proxima Centauri remains invisible to the naked eye due to its apparent size of just 11.13 magnitudes, far beyond the limit of human vision. However, don't let that fool you. Proxima Centauri is still a star worth studying. Red dwarf stars like Proxima Centauri are among the most efficient in terms of energy reproduction. While they may not emit much light, the convection process at their centers keeps them shining for trillions of years. In fact, Proxima Centauri will remain a main sequence star for another 4 trillion years. However, the habitability of a red dwarf like Proxima Centauri is still debated. For one, it's a flare star, which means it undergo frequent and unpredictable outbursts of radiation. As a low-mass star, its habitable zone would be much closer to it than the Sun's, likely between 0.23 and 54 cents. Yet even this zone might not be as hospitable as it seems. Proxima B might not have a stable atmosphere, which is essential for maintaining conditions suitable for liquid water on its surface. Without this stability, life would be vulnerable to space weather, making it incredibly difficult for life to thrive. So while Proxima B might seem Earth-like on the surface, it is far from being able to support life. Still, many scientists continue to hold hope. One tool that has captured the attention of astronomers is the James Webb Telescope. After several delays, the telescope was finally launched in 2018 and is poised to help determine if there is life on Proxima B. However, as with everything in science, things are never as simple as they appear. Several modifications were necessary to ensure the James Webb Telescope could deliver precise images. As Abby Kaner, a Eichel physicist at Harvard, explains, if a planet like Proxima B absorbs light from its star, it can also RIT that light as infrared radiation. The James Webb Telescope was specifically designed to detect infrared light, allowing it to capture images of this radiation from the planet's surface and search for patterns that could confirm whether the planet has water or an atmosphere. But what if the planet's atmosphere is unsuitable for life? The mere presence of an atmosphere doesn't guarantee life, warns Ed Turner, an astrophysicist at Princeton University. Proxima B could be like Venus with a thick atmosphere much denser than Earth's, leading to extreme heat that would make life impossible. The mission to uncover the truth about Proxima B is not without its challenges. While the James Webb Telescope holds promise, there are many factors to consider with costs mounting. Space scientists are feeling the pressure to find a way to study planets like Proxima B. The stakes are high, but the rewards are even greater. The chance for a glimpse into the unknown, to uncover the secrets of a planet that could harbor the potential for life, is something any serious scientist would strive for. But could we even travel to Proxima B? It's the closest exoplanet to us, which makes it exciting. It's almost like exploring our own backyard. Even more interesting is the fact that it's nearly the same size as Earth. Its position in the habitable zone suggests it could indeed have conditions suitable for life as we know it. Proxima B's proximity also makes it a viable target for our search for life beyond Earth. At just 4.2 light-years away, it's an ideal candidate for interstellar missions. Now consider the feasibility of exploring this Earth-like exoplanet. However, we can't go there just yet. It's certainly on the radar for future missions as technology progresses and makes such journeys more accessible. It's one of the most remarkable possibilities in the field of space exploration. However, it's no simple task to get there. It would take 75,000 years for spacecraft like Voyager 2 to reach the Proxima Centauri system. However, a proposal has been made involving solar sails, ultra-thin sails that could be used to accelerate a spacecraft to the Alpha Centauri system in Proxima. Along with it, this technology uses solar pressure to keep the spacecraft on course, eliminating the problem of running out of fuel. With anticipated speeds of 10 to 20% of the speed of light, the journey to the Alpha Centauri system could be reduced to just 20 years. The discovery of Proxima B has reignited humanity's interest in space exploration. It has given us a renewed sense of hope that we are not alone in the universe. The James Webb Telescope is a marvel of modern technology, capable of taking us back to the very beginning of the universe 13.7 billion years ago. This is the carefully preserved mystery. The farther an object is, the longer it takes for light to reach us. This means the James Webb Telescope can observe objects in the universe farther away than any other telescope before it. Additionally, it can detect these objects in longer infrared wavelengths of light, allowing us to see more distant stars with greater clarity than ever before. And here's something even cooler: this incredible technology can provide insight into the possibility of life on other planets like Proxima B. However, like with everything, there are some notable limitations. The presence of an atmosphere doesn't necessarily guarantee life. Proxima B could be like Venus with a thick, inhospitable atmosphere. But get this, the James Webb Telescope can detect such conditions if they emit just 5% of the planet's side brightness. While 5% might not sound like much, it's quite significant when dealing with a star that is generally dimmer than our Sun if Proxima B has intelligent life. They may be using bright orbital mirrors to reflect sunlight from the day side of the planet to the night side. How cool is that? There are countless exoplanets waiting to be discovered in our universe. These planets come in all shapes and sizes, with some being massive gas giants while others resemble our own Earth. One type of exoplanet that has grabbed the attention of space experts is the gas giant. These planets are similar in structure to Jupiter and Saturn but are much larger. Some of these behemoths have been named super Jupiters, surpassing even the largest planet in our solar system. However, that's not all. There are also hot Jupiters, gas giants that orbit incredibly close to their host star. They exist in a scorching environment with temperatures high enough to melt metal. Imagine being able to observe such a planet up close with its raging storms and intense heat. In addition to gas giants, there are also Neptunian exoplanets which are similar in size to Uranus and Neptune. Among these are hot Neptunes and mini-Neptunes, which are smaller and closer to their host stars than their gas giant cousins. These planets are often shrouded in mystery, making their atmospheres hard to study from afar. Moreover, we shouldn't forget about terrestrial exoplanets, those that resemble our own Earth. These planets come in various sizes, from smaller than Earth to twice its size. There are also super Earths which have masses greater than twice that of our planet but are lighter than Neptune. One of the most captivating exoplanets discovered recently is Proxima Centauri B, which orbits the star of the same name. This planet is classified as a super Earth with a rocky mass 3 times that of Earth. Despite being close to its host star, it is still far enough away to be considered outside the habitable zone. Proxima Centauri B isn't alone. It has a companion, Proxima Centauri C, which orbits farther from the star. This planet has an orbital period of around 5 Earth years and was discovered in 2020 using pre-recovery Hubble data. What's even more fascinating about Proxima Centauri C is that it appears to be an incredibly bright world, possibly due to the presence of a ring system. More discoveries, however, remain to be made in the Proxima Centauri system. In 2019, astronomers identified a change in the star's rotational rate which could be the result of another planetary companion. If confirmed, this planet would be called Proxima Centauri D, and it would be roughly the size of Mercury or Mars. Imagine a reality where the night sky is filled with stars as well as countless other planets, each with its unique attributes, and orbits. The universe is full of surprises, and exoplanets are just one of them, with new discoveries being made constantly. It's an exciting time to be a space expert. While we don't yet have an exact count of exoplanets, we know they exist in abundance throughout the universe. Exoplanets aren't easily detectable. Takes advanced technology and powerful telescopes to spot them. These planets are often hidden by the glare of their host stars, making them difficult to study. However, with advancements in technology, direct imaging of exoplanets is now possible. For an exoplanet to be directly imaged, it needs to be large enough to be visible to the telescope, far enough from its host star to avoid being obscured by its glare, and young enough to be hot and visible from Earth. These requirements limit the number of exoplanets that can currently be imaged, but they offer a fascinating glimpse into the properties and evolution of these distant worlds. Exoplanets are typically discovered through the effects they have on their host stars. The gravitational pull of an exoplanet can cause its star to wobble, and this change in the star's motion can be detected by astronomers. The Kepler Space Telescope used the transit method, which measures the dimming of a star's light when an exoplanet passes in front of it. This method has provided an abundance of data About exoplanets, including their size, distance, and temperature, here are a few interesting facts. Did you know that more than 22% of stars like the Sun have Earth-sized planets in their habitable zones, or that TRAPPIST-1 is home to 7 rocky exoplanets with water on their surfaces? Exoplanets in our solar system can also have natural satellites, known as exomoons, with more than 4,000 exoplanets discovered so far. We know they exist in abundance throughout the universe. Hot Jupiters, with their massive size and rapid rotation, are the easiest to spot. However, there are countless other exoplanets waiting to be found. NASA's James Webb Space Telescope is unveiling the secrets of the universe, one discovery at a time. The telescope has been gathering data and capturing stunning images of the universe, revealing previously unknown wonders. Recently, it made a pivotal discovery that will forever change our understanding of the cosmos. But that's not all. The James Webb Space Telescope has been busy capturing breathtaking images and collecting data about the universe. The stunning photos of star systems and dust clouds swirling and crashing into each other are truly mesmerizing. The discoveries continue to pour in as a global community of space experts utilizes the telescope to compile a detailed catalog of the coldest ice ever observed in a molecular cloud. They identified frozen versions of various molecules, including carbon disulfide, ammonia, methane, and several common organic molecules like methanol and water.